Hi viewers, I am creating these videos to help teachers of maths support their learners in making sense of mathematical concepts and their associated procedures and processes. And today I'd like to talk about how we can introduce formulae. And the way I'm going to introduce formulae here is to use Cuisenaire rods. And this is only one way that you might potentially introduce formulae. There are lots of different ways. But the nice thing about Cuisenaire rods is, particularly if pupils have used them a lot for representing different numbers. So being able to represent integers, being able to represent fractions and decimals with Cuisenaire, then actually they're already used to the idea that each of these rods could take a variable length, could take any length. And you can see I'm using here the manipulative, the online virtual manipulative to help me, which has the option to have these rods labeled by their letters rather than as any particular value. And so how I might start with something like this is just to take, say, the blue rod, and that's got a label of B. It's kind of hard to see because of the color, but that's got a label of B for blue there. And to say to learners, right, find as many different combinations of rods as you like that are equal in length to the blue rod. And so what they might do is might simply start with, say, the brown rod, which is labeled T for, I think, tan, not something else. But the brown rod plus the white rod, or they might show it as black plus red. They might get creative and show it as three greens, or even as something like two purples plus a white. You know, there's loads of different combinations that they could produce there. If they were feeling very clever, they might even do something like two yellows minus a white, or we might prompt them towards something like that. So then what we're going to do is say, right, well, we already know, and this is where, you know, having worked with Cuisenaire rods a lot and having worked with models of addition and subtraction using Cuisenaire, they already know that this means that the T plus the W is equal in length to the B. And that's true no matter what values those rods take. That's the important thing there, because that's what we're seeing now. What learners should be seeing here is the generalization of relationships and associations that they've already made before. You know, and this might have started life as 8 add 1 is 9. It might have become something like 8 ninths add 1 ninth is 9 ninths. It might have become other things. But at its heart, it's always been these two rods combined to make the same length as this rod, and we can express that algebraically. T plus W equals B. And we could clear there when we're saying that, we're talking about the length of the brown rod plus the length of the white rod is equal in length to the blue rod. Okay, so the length representation of those numbers is still at play here. It's just now we're saying it doesn't really matter what those numbers are. We've seen them be lots of different things. Yeah, we've seen them take lots of different values, fractional, decimal, whatever. But this is always true. Okay, and then similarly, of course, we can write some of the other ones. We can write things like B equals little b plus r, little b here being the black rod, of course. And we can start to bring in multiplication here. So rather than b is g times g plus g plus g, b is 3 times the length of the g rod. Or b is 2 times the length of the pink rod plus the length of the white rod. Or even that b is 2 times the length of the yellow rod minus the length of the white rod, particularly if we have seen this model for subtraction before, forwards and then backwards for subtraction. Okay. Now, as well as this, of course, what we get from this, which is brilliant, is because if pupils have seen sort of part whole models using these things and stuff like that, then we get rearrangement of simple formulae quite naturally from this. So we can take this and we can just look at this top one for a minute. And we can say, well, we can see that as t plus w equals b, or b equals t plus w. But how else could we see that? Well, again, if we're used to sort of models for addition and subtraction with these things, we could see that alternatively as b minus w equals t. Forward then back equals t. Or we could see it as the difference between b and t is w. And so that will be b minus t equals w. And we can look at it like that if pupils are familiar with those models of addition, those models of subtraction around part, whole, or, forward and then backwards, or, the difference between two and what fills the difference, what fills the gap. And if they've used models like that in the past, then this is brilliant because we just get those as natural extensions of this extension to the idea of formulae and to using Cuisenaire rods for the general length rather than any specific length, because I've seen those rods take lots of different values. So it doesn't really matter what they are. And of course, I could do the same thing here. I could do very similar things. When I look at something like this, I could be saying, well, I could see this as B minus G is 2G, or B minus 2G is G. But another way I could look at that is to say that if I take this length of B and split it into 3 equal parts, so if I take this length of B and split it into 3 equal parts, then I get the length of G. And we're getting that multiplication and division inverse, aren't we? Okay. Alternatively, again, they need to have used and need to be familiar with a comparative model of division here, but I can get B over G is 3 from this as well. I could say, well, how does B compare to G? If G was 1, B would be 3. So B compares to G in that it is 3 times greater. If that G was now defined as 1, B would be 3. So B compares to G as 3 compares to 1, literally. Okay. And, I can do things with this one as well. If I bring in the pink and the white now and say, well, okay, I can see that as B minus W equals 2P. I can see it as B minus P equals P plus W. Yeah, the difference between B and P is P plus W. I can see it as B minus 2P equals W. But importantly, I could also see it as if I do B minus W and I split that the remaining distance in half, I get a single P. And obviously that leads from this one. If I do B minus W and then I split that remaining distance in half, that gives me a single P. And we've got all three sort of standard rearrangements of that formula, all three different variables as the subject there. And I can do exactly the same thing here. I'm going to adjust this slightly now that they're directly next to each other and put the white there. So I could see that as B is 2y's minus W, or I could see it as, I'm going to bring it down here and hope I have room. I could see it as B plus W equals 2y. Yeah. Or I could see it as the difference between B and Y, the difference between B and Y is Y minus W. But of course, what I can see it as, again, coming from here, is I could see it as the difference between 2y and b is w, or I could see it as, and that's the one that comes from here, if I do b plus w and then split that length in half, then I get y. Yeah, and if I would say, if I want the rearrangement for it in terms of w, which I'm going to put just here now, and sorry, it's got a bit confused, but I got a bit excited with all my writing. Then I can say, well, I can see, or maybe not from here actually, maybe from here, I can see, not from there even, apologies, from here. Let's put it, try and squeeze it under there. I've seen that b plus w is 2y. But therefore I can see that the difference between 2y and b is w. So that the difference between 2y and b is w. And that gives me the rearrangement of that one for w. Okay, and apologies that that's got a little bit confused, but hopefully it's clear that if I ignore that, in fact, I'll rub that bit out, and I ignore that, these two have come from here, these two have come from here, these four have all come from that one, and then similarly all of those have come from the bottom one, including going from here to that last one underneath there and going from here to there. So you probably gather I'm quite excited by that idea, because that idea really is the culmination of pupils working with numbers and the rods with numbers in many different formats, decimals, fractions, all sort, integers, negatives potentially if we set them up on an axis, all sorts of different ways that we work with these numbers. But at their hearts, the relationship between the lengths of those rods is always the same. And so we can express that algebraically. We can express that just using the letters to stand for the length of each rod, and start to form those relationships using algebraic notation and manipulate those relationships using algebraic notation, seeing them in different ways. So that's my short video on Formulae and using Cuisenaire rods in particular to work with Formulae. As always, I'd like to say a big thank you to mathspot.com and its creator, Jonathan Hall, who's produced this fantastic website, which not only has all the manipulatives that I'm using to help bring you these videos, but loads of other tools on there for teachers of maths. I say it every time, but if you have not done it yet, make sure you get into that website. You will find it useful for your practice, I can pretty much guarantee. And as always, if you are interested in visuals and manipulatives and using them to help your learners in making sense of maths concepts and the associated procedures and processes, then please do consider checking out my website. My website is visiblemaths.co.uk. And on that website, among the many different things you'll find on that website, you will find in the sort of publication section a link to my book, which is also called Visible Maths. The book came before the website. And there's a link to the publisher there. The publisher is Crown House Publishing. And on that link, you can see some sample pages. And if you think that it would be a useful addition to your teaching and learning library, either your personal one or for your school, then you can, of course, place an order. I will be making these videos throughout lockdown and potentially beyond where I get time. So if there is a video, for a particular concept or process or procedure that you feel like you would want to see using manipulatives and how we can use manipulatives to help learners make sense of it, then please do get in touch and I will try and get around to making it for you. Thank you very much for your kind attention.